Okay, so this is going to be your test review for test number 11 through lesson 44. I'm going to start with just going over a few problems that have been common mistakes that I've seen on your last few tests. So the first thing will be to look at the laws of logarithms. So the first law of logarithms that we're going to look at is log BM plus log BN is equal to, so in order to combine these two logs, if you see a plus sign between them, you're going to take the two variables and you're going to multiply them by each other. So this would give us log B of M times N. Now, if you look at a problem that's in the book, we're going to look at log base A of 3 plus log base A of 4 is equal to log base A of x minus 2. Now, if I see a plus sign between my two logarithms based off of the law of logs, in order to combine them, I'm going to take these two variables and multiply them by each other. So this left-hand side of the equation is going to become log A of 3 times 4 is equal to log A of x minus 2. Once you've combined them, then we can get rid of our logarithms by raising both sides to the power of a, and that's how you'll solve for x. So if I raise it a to the log a to the log a, that's how our logs cancel, and you are left with 12 is equal to x minus 2. So that's the first law of logarithms that we're going to look at. The second one is going to be the log BM minus log BN. So log BM minus log BN. Now, if I wanted to combine these two logarithms and I see the minus sign in between it, that indicates to me that I'm going to divide. So I'm going to take my two variables m and n, and you're going to combine them to one logarithm to become log base b of m divided by n. Now, if I look at a problem in the book that's similar to that, I would have log base 3 of x plus 2 minus log base 3 of x minus 1 is equal to log base 3 of 4. Now, right off the bat, I see that there's a minus sign between my two logs. So in order to combine them, I'm going to divide. These are my two variables, so it would be log base 3 of x plus 2 divided by x minus 1. The right side will stay the same, log base 3 of 4. Now that I've combined the logs, I only have one log on each side. That's how I know I can get rid of my logs. So I'm raising it to the power of 3, so 3 and log 3 will cancel. And now I have x plus 2 over x minus 1 is equal to 4 over 1. And to solve, you can just cross multiply and then solve for x. Now, our next one is going to be when there's a number outside your logarithm. So that would be x times log base b of m. Now, what do I do with this number that's on the outside of my logarithm? Well, it becomes the exponent of the number. So that means this would be equivalent to log base b of m to the power of x. So if I look at one in the book, I have 3 log c of x is equal to log c of 27. So I see the number before my logarithm. It becomes the exponent of my number, and in this case, it's the x. So this would be log c of x to the third is equal to log c of 27. Now, just like the other ones, now that we only have this log left, we're going to raise it to the power of c. So it would be c to the log c, and that's how it cancels. And now you can solve for what x is equal to, because we have x cubed is equal to 27. Now the last thing that I want to look at is when your log's base and the base of your number next to it are the same. So if I gave you log base b of b to the power of n. Well, if my log's base and the base of the number next to it are the same, they actually cancel each other out and you're left with n. So let's say I gave you the function log 4 of 4 to the second power. Well, I would see that my log's base and the base of the number next to it are the same, so therefore this is just left with 2. And that's our review of our laws of logarithms. Now we're going to look at some of that new material that's going to be covered. So the lessons 41 through lessons 44 is what the test is going to be over, in addition to any review problems. And the first thing that I want to look at is called permutation notation. And what that notation looks like this. So a small n, a big P, and then a lowercase r. And this formula, which you have to memorize, is going to be n factorial over n minus r factorial. Now, there's a couple ways they can ask you to do this problem. They could ask you just to evaluate the problem and find it. They could ask you to find 2 of them and then find the difference between them. But we're just going to look at the example on page 298. And that is to find 12p4. So if I follow the equation that I gave you, it's going to be 12 factorial is going to be your n. And in the denominator, I'm going to have 12 minus 4 factorial. So if you're doing this by hand and then using your calculator, I would recognize that this would be 12, 11, 10, 9, and then 8 factorial. In my denominator, I have 12 minus 4, that's 8. So that would be 8 factorial. And then I can see that my 8 factorials would cancel. And you would just be left with 12 times 11 times 10 times 9. And you would need to multiply that out in your calculator. Now, in addition to finishing the logs that I gave you from before, I also would like you to practice this problem by evaluating 10p4. 10p4 using that same formula. When you check your answer will be from problem set 41, number 8A. So I want you to evaluate that. Now we're going to move on and look at problem set 42. And the topic that I want to look at from lesson 42 is going to be the constants in exponential functions. So I'm looking at page 304. And I'm going to graph 3 to the power of negative x. Y is equal to 3 to the power of negative x. Now, when I look at 3 to the power of negative x, I actually could take this apart and make this 3 to the negative 1 and then to the power of x. I know that 3 to the negative 1 is equal to 1/3 to the power of x. So when I graph that, if you remember from when we first learned about exponential functions, anytime your base is less than 1 but greater than 0, it would start on the right side and grow exponentially from right to left and would look something like this. Now, if there's a number in that exponent, like on page 305, I have y is equal to 1/2 to the power of 2x. So another way, if you forget how to separate out that exponent, would be to make an x and a y chart. So I'm going to start with -1 0, and 1. Now, if I were to put -1 into this exponent, I would have 1/2 to the -2. 1/2 to the -2, I would have to flip it, and that would make this equal to 4. When I plug in 0, 1/2 to the 0 is going to be equal to 1, and then 1/2 to the 2 would be equal to just 1/4. Now, when you draw this, 1, 2, 3, 4. It's going to be a little tricky, but at -1, you're going to go up 4. At 0, you're going to go up 1, but at 1, you're only going to go up 1/4. So you would draw an exponential line that looks something like this. Now, what I want you to do is I want you to try one of them. And I would like you to try and do number 9 on lesson 42. So problem set 42, number 9, which is y is equal to 1/2 to the power of x minus 2. Now, the last thing I want to look at is going to come from lesson 44. So in lesson 44, we started talking about abstract rate problems. Abstract rate problems. And in this, we use the formula cost per item times the number of items equals the amount that we're spending. So this is the equation that we're starting with. Now, we're always going to start by solving for the cost per, which is also known as our rate. So if we look at page 315, I'm looking at the first example. It says Peter purchased P pencils for D dollars. So all I'm looking for is I'm looking for solving for that cost per, or my rate. So the cost per, I know that he is purchasing P pencils for D dollars, which means that the cost per pencil is going to be D over P. And that all comes from the first sentence. Then it says that if the P pencils had cost X more dollars, how many pencils could Peter have purchased for $20? So it's saying that each pencil is going to, or that the P pencils is going to cost actually X more dollars. So in addition, we're going to add X. So our new cost per is going to actually be D plus X over P. Now it says, how many pencils could Peter have purchased for $20? So I have my cost per at D plus X over P. I'm solving for the number of pencils, and I know it's going to cost $20, or that's how much I have. So then to solve for the number of pencils, I'm going to multiply both sides by the reciprocal, which will give me that I will end up with 20P over D plus X pencils. And now what I want you to do is now look at the next example. So the next example is going to be the coach purchased B basketballs for X dollars. If each basketball had cost $3 less, how many basketballs could the coach have purchased for $200? So again, I'm starting off with this equation, cost per times number equals the amount that we're spending. So this is example 44.2. And I'm starting with solving for the rate. So the cost per times the number of items equals the amount that we're spending. And I'm only using the first few variables that were given. It says B basketballs for X dollars. So my cost per times the number of basketballs, which would be B, equals the X dollars that they're spending. The cost per ball is going to be X over B. But then it says each ball had cost $3 less. So this is our cost per ball. Now I'm going to be subtracting it by 3 because it's $3 less, meaning that our new cost is going to be X minus 3B over B because I want a common denominator there. Now I have my rate, or my cost per. It says, how many basketballs could the coach have purchased for $200? So I go back to this equation. I know what my cost per is equal to. It's X minus 3B over B. I'm trying to solve for the number of basketballs. And I know that I'm going to be spending $200. Now, just like the last one, in order to get that by itself, you're going to multiply by the reciprocal, which means that you end up with 200B over X minus 3B, and that's the number of basketballs. Now, I want you to try one like this, so I want you to look at number 1 on lesson 44. So problem set 44. Number 1, and that's how you can check your answer as well. So the drummer boy purchased D drums for X dollars. If each drum had cost $5 less, how many drums could the boy have purchased for $100? So in order for you to receive extra credit for going through these with me, I'm going to need you to submit your notes as well as all the problems that I've asked you to try and the answers for the logarithm problems. And that needs to be submitted to me by email by taking a picture of your notes and submitting it to me by midnight tonight. Have a great day.